Hello everyone and welcome to lecture number 6 US182 which is area robots. So today I gonna teach you basics of this area robots. As you know, in previous week I teach you what is this industrial robot. Also we had the presentation of the students about field robotics, and also I described the structure or characteristics and application of industrial robots. This week I'm gonna teach you the area robot, structure of area robot, challenge of using this area robot, and application of area robots. So as usual, I start with the history of each robot. In 19th actually, beginning of 19th, UAVs innovations started actually at that time. And in 1915, Nikola Tesla, he's very famous scientist, he described a fleet UAV. UAV, it's abbreviation of unmanned aerial vehicles. In 1955, Beechcraft company offered Cardinal for US Navy, which is this one. So actually this type of robot is not actually so much new robot. It started long time ago and they joined the First World War and Second World War. But it was not modern as now we have, like this drone and those stuff. It was with wings. In 1960, US Air Force decided to intensify the use of UAV. Why? Because they lost a lot of soldier in the war, especially as I remember in the Vietnam, they lost a lot of soldier. So they start to think about creating some unmanned vehicles, which is vehicle without any human inside. So they create U2 incidents, which is this one. In 1964, America initiated highly classified UAV called Rian, which is this one. And 1980s, Japan developed a UAV for safe application, which is agriculture purposes. This is Yamaha R Max. In 1990 and so on, application boosted actually in this field, and now we have a lot of unmanned aerial vehicles with many applications actually. First one, Yamaha R-Max. He is controlling this one. So nowadays we can see many modern UAV like this NASA Predator. This is, I mean, we're very famous. Drone for research like this one, also very famous. Drone for kids like those small, very small one, and so on. So what is unmanned aerial vehicles? Unmanned aerial vehicles. It's a system capable of sustain a flight with no direct human control. So it means there is no man inside the cabin who control the airplane or this vehicle like the normal airplane. There is the control, but let's say remote control or maybe some autonomous control. So it can perform some specific task like fertilization, rescue stuff, firefighting stuff. There are many applications actually for this, even for entertainment stuff as well. So UAV can be controlled in two ways. Either, I mean, you can control using the remote control. So it means there is human control, but not direct control. It's indirect control. And also fully autonomous using onboard computer. And here I saw two examples. One of them is with wings, you can see here. And this is without any wings, only we have propellers. So let's now compare between unmanned and manned vehicles. So if I say manned vehicle or unmanned vehicles, manned it means the vehicle which is controlled by a human, but the human is exist inside the vehicle itself. As you see here, the man is exist inside the cabin. But if there is no human on inside the cabin, it's called unmanned vehicles. Unmanned. So it's actually the existence or non-existence of human operator inside the vehicles. So let's go for components. As always, I explain about the components for each robot. As I told you, most of the robot has the same components. First, start with body. But here the body of unmanned vehicles is different, especially the one without wing. We have it depends on number of arm, tricopter, quadrocopter, hexacopter, and so on. But this is if we have no wing. We have also unmanned vehicle with wing is different. Actuators mainly DC motors usually they use. They don't use AC motor for sure because they are using battery for that. Propeller, this is very important for the flying. So it's kind of fan. We call it propeller. Power supply, usually a Li-ion battery they use or hydrogen and so on. We have flight controller, which is exist inside the unmanned vehicle. And also the important stuff which is exists may be different from other robot, which is communication unit. Because I mean, either if I control autonomously or remotely, both of them I need some communication unit because the vehicle is flying in the sky. So we need to get information and send information. So receive and transfer information. Because of that, we need some communication units. And sensor, more or less, they are using gyro sensor. Why gyro sensor? In order to know the orientation of the vehicles itself. So orientation, or let's say orientation, or the direction of the vehicle itself. So let's go for the type. This is a tricopter frame. It has three arms from fiber carbon. This is quadrocopter frame. It's I think plastic type here, but for sure the material is depend on the company. We have here hexacopter frame. It has 6 arms, and this is octocopter frame. It has 8 arms. And this is the actuators. Is kind of very small DC motors. It's brushless DC motor. Brushless DC motor. Over this we install the propellers in order to fly. And this is communication units. Let's say remote control. Also I have communication module inside the cabin itself. And we have gyro sensor. Maybe it's not this type, maybe different type. Just I'm showing you the example. And we have power source, kind of battery. What is gyro sensor? Gyro sensor, it's called angular velocity sensor as well. It's type of sensor. We can find it in many actually device, not only drone. Also, we can find in our telephone. When you rotate your telephone horizontally, vertically, the screen change, the shape did change. Why? Because of this gyro sensor device. So it can detect the change in orientation or vibration and motion. Okay. So any change in orientation or vibration, it directly it can detect. So we can use it in game of smartphone, area robots, camera shake correction look. I mean, if I have some shaking, I can correct this shaking using this gyro sensor. So let's go now for the challenges of the UAV. First important challenge is the regulations because it's very freedom device. so it can access to many areas. Because of that, it will be dangerous. Maybe, and I mean, nowadays drones is very small, so maybe it can enter to some military areas. It can take a photo, take a video. So it's dangerous. So we need to have some authority for this. So this is very important. Another, human-machine interface. I mean, there is no standard, unfortunately, up to now. So the interface between human and machine is not easy stuff, because I mean, wide range of autonomy is using to control this. Maybe adults, maybe big old guys, maybe kids they control. So I mean, we have many. So there is no standard for interface, and also the mission also is different. We have many type of mission for this. Plus the operator skill. Some operator are very skilled, they can control drone very easily, but some of them they are still not so much good. So because of that, human machine interface is one of the big challenge. And this is good example in Singapore about the regulation. They have one park. They put some rule inside this park. For example, know the characteristic of aircraft and how to fly. For example, do fly only in good visibility and weather conditions. So they are putting some instruction, and within this instruction you can choose your drone. For example, this another regulation which we should avoid. This is all in Singapore. Don't fly an aircraft weighing more than 7 kilo, for example, because it will be dangerous if it's dropped down. Don't fly the aircraft over any crowd, because also it will be dangerous if it fall down. For example, don't fly within 5 kilometers of any airport military, because also it's very secure area, so it's dangerous. So there are many regulations for that. Continuing for the challenges, navigation, okay, which is monitoring and controlling the movement of UAV from one place to another. Because I'm not inside the cabin, I should know where my drone is going on, where is my UAV going on. So I need a navigation system for that. So navigation system is the challenge to develop the technology allow UAV to live without human-made external navigation infrastructure. What I mean by that, I know that GPS, it can localize the drone or the unmanned vehicle, but sometimes if we have no signal, what will happen? So the drone will be lost. So we should overcome this challenge in order to detect or localize the position of and orientation of the drone or unmanned aerial vehicle. So it's actually a big challenge. Another thing, obstacle avoidance, because it's moving very fast. So if there is some object in the sky, maybe it will hit. So obstacle avoidance is also one of the big challenge because of the high speed. Landing is another problem, because it's not endure device. Maybe it will made of plastic, some type fiber carbon. If it's fall down very quickly or in wrong way, it will break down. So we need also to have some skills in order for landing. It's not easy to land. Let's go for the application. For the application of these unmanned aerial vehicles, we have many applications actually. Remote sensing, such as mapping, volcanic sampling, and entertainment. We have disaster response, like flood monitoring, chemical sensings, and so on. I will show you later on some videos about that. Search and rescue, like helping human to survive in hard to reach areas, like ocean, some nuclear areas. Surveillance, like traffic monitoring, coastal patrol, and so on. Transportation, including small and large cargo, for example, like Amazon Prime. This is one of the good example. Image acquisition for real-time entertainment also is used, and military applications. It's also, historically is famous here. This is remote sensing, remotely control unmanned aerial vehicles. This is disaster response. It can go to some area which is difficult to reach, volcanic area, nuclear station, ocean, and so on. Here, rescue and search and rescue. There are also many applications. It can help the human in some dangerous area and survive them and save them from any problem. And we have this is transportation, which is cargo. Amazon Prime, they apply this technique now nowadays, and is very successful actually. And this is another image acquisition type. It can detect and acquire the important information from the sky. And military purposes, historically, they have it. They have it. Long time ago. Let's go and see the video of UAV applying the transportation. So this is Amazon Prime. I like it too much. It's very successful. It has many challenges as well, but actually it is very successful. They applied it in many states. Yes, you can see. Okay, guys, for this transportation or cargo drone, actually we have many challenges. What are those challenges? Actually, I can summarize them in 5. Air traffic problem, especially if many companies employ this concept. Now, Amazon, they apply this. And also some other company, but if we have too much company they apply this cargo idea, we will have another traffic in the air. So we should also solve this problem. Maybe we need some type of road as well, air road. The problem of safety, because it's light stuff, anyone can steal it, anyone can hack it, anyone can use the gun in order to drop it. So if we have some important stuff inside, like jewel, almond, those stuff, it will be maybe dangerous, not safe. So the weakness of flying for long distance, as I know, the most good drone, it can fly for maybe 4 hours. Maybe they are more now, more high technology. So if I want to go to some area which is very far, maybe it's not also possible with this cargo. The condition of the weather, if it's windy, snowing, raining, so not also suitable for all type of drones. And delivery place, maybe the delivery place, it will be somewhere inside the forest, or maybe it will be in crowded areas, so anyone can steal this object. So there are many challenges actually for this concept. Now I would like to give one example about the drone for military purposes. You can enjoy this.
Выстрел!
You can see it's military purposes. They are assigning one object and hit it by the missiles. So this is Russian combat drone. You can watch it again if you want using this link. I provide the link. So now let's go for swarm drone.
We developed a nano quadrotor capable of agile flight.
It's many multiple drones together combined to do one application. This is from Pennsylvania, USA.
Multiple vehicles can fly as a formation. We developed a method to transition between formations in 3D. The team can also navigate in environments with obstacles.
So this is, you can see it's moving very smoothly to form number 8. Okay, so let me show you also last video. Back in China, 1,000 drones they use for some show. They are doing the 1,000 drone with some lightning Okay, thank you for listening to lecture number 6, and see you next week with more interesting robots type. See you and bye bye.